Hey, so this practice, let's talk about the least common denominator. How do we find the least common denominator? Okay, so now look at this. We have 2a to the cube, 6a to the fourth, b squared, 4a3, and b to the 5. So now let's find the common denominator of this number. So if you can see it right away, we can just find one by one. So let's look at the number. We have a 2, 6, and 4. The common factor would be 2. So after divided by 2, we have a to the 3, a to the 4, b squared, 3a to the 4th, and then a to the 3rd, and 5 to the 5th. And then the next is we can start in with the letters. They both have a, so you have a cubic, and then a to the 4th and a to the cubic. So they totally have 3 a's in common. So after that, you have one left, and then 3a b squared, and then 2 times a to the 3rd all goes being factored out. So we only have b to the 5th left. So the common factor should be on here, which is 2 times a to the 3rd. Now let's take a look at another example. Let's look at a little bit complicated one, such as x squared minus 25, and then x plus 5. What do they have in common? So it looks like they don't have things in common, but the first thing you can do is trying to factor them out. So x squared minus 25, we can factor as x minus 5 times x plus 5, and then x plus 5. So what do they have in common? Well, x plus 5, you can see as a whole, so they have a common factor of x plus 5, right? So that means the common factor is x plus 5. Let's do another one. Another one such as x squared plus 3x plus 2, and then x squared plus 5x plus 6. So what will be their common factor? So again, we need to factor this out. So I have by AC method x plus 2 times x plus 1, and here I have x plus 6, 2 and 3, also AC method. X plus 2 times x plus 3. Okay, so what do they have in common? X plus 2 and then x plus 2. So this is our common factor. Now I'm going to change it. I'm going to ask you, hey, what is the least common denominator? How do you find the least common denominator? It's quite similar. You just need to find out the missing part. For example, they both have x plus 2, right? So for the first polynomial, what do they miss? They don't have x plus 3. So that means I need to add another x plus 3. So for the second one, they both have x plus 2 and they have x plus 3. So what do they miss in is x plus 1. So the least common denominator would be x plus 2 times x plus 1 times x plus 3. Let me give you another example. Let's look at the function. Okay, now let's look at these two rational functions. We don't need to care about the top, which is the numerator. We just need to look at the denominator. Let's try to find the least common denominator. First step, always trying to factor it out. So for the first one, when you factor it out, you have x plus 6 times x minus 6. the sum of differences. The second one, you can use AC method, or you can see it as the perfect polynomial, which is x plus 6 squared. Okay, so now how do we find the least common denominator? Okay, x plus 6. Okay, you might say, okay, they both have x plus 6, x plus 6. Okay, this is too big. So the missing part is what? Just x minus 6. All I need to do is just times x minus 6 on the second one. So this is yes and no, because if you look at the second one, they actually not just have x plus 6, they have 2x plus 6. Okay? So instead of looking at it as x plus 6 squared, you can see it as x plus 6 times x plus 6. So now look at these two functions. What do they have in common? They have one x plus 6 in common. So that means they're missing another one. So that means the first function, you need to times x plus 6, and then for the second one, you need to times x minus 6. So now they have the same common denominator, 2x plus 6, and then 1x minus 6. So this is a tricky part. Make sure that you be careful when you see the square. Just like, okay, when you see a function look like 4a, and then 4a, let's use 3a squared. Are they the same? No, because you know that the first one is missing an a, so you need to times a on the top and the bottom. So the common denominator should be a squared, not just a. So this one is similar. Okay, I'm going to do one last one. Let's have 3x plus 1 over x squared minus x minus 12, 2x over x squared plus 4x plus 3. Okay, first step, always trying to factor them. I have 3x plus 1, and then x minus 4 times x plus 3. Again, use the AC method. Try to work on it by yourself. You can pause the video anytime that you want. And then the second one, I have x plus 3 and then x plus 1. Okay, now take a look. What do they have in common? They both have x plus 3. So which part they missing? So for the first one, the difference is x minus 4. The second one is x plus 1. That means we're always trying to multiply the missing part. So that means I want to multiply x plus 1 for the first one. For the second one, I want to multiply x minus 4. So now let's look at their denominator. They are the same. So the least common denominator would be x plus 3, x plus 1, and then x minus 4. Okay, so that's it today. Good luck. Let me know if you have any questions.